This is our breadboard with the components. Okay, so we have 5-volt power supply going in here. This is our voltage divider element. Here's our thermistor. And this is our R2 going back to potentiometer. So our thermistor is R1 and R2 is a variable resistance with the potentiometer. The voltage output from the voltage divider is going to the base of this transistor. And when that exceeds 0.7 volts, or in my case 0.8 volts, just to be sure, what happens is it allows current to flow from +5 through the coil of the relay, through the collector and emitter to ground. That will switch the coil on the relay, which will change the contacts on the relay. Now currently the contacts on the relay are, we have common, normally closed. So we have the LED on. When we activate the coil on the relay through the transistor, the contacts will switch from common to normally open and the LED will go off. And we just take a little side view again at that, just in case it wasn't clear. Power source, potentiometer, thermistor R1, potentiometer R2, transistor, relay, and LED. As I say, relay is connected through common, normally closed, LED on. When we switch the relay will switch from common, normally closed to common, normally open, so the LED will switch off. So let's see it in operation. So what I'm going to do is use a heat gun to increase the temperature at the thermistor, which will then energize, if you like, or activate the transistor, which will allow current flow through the relay, collector, emitter, and switch the relay from common, normally closed to common, normally open, and the LED will turn off. So a bit of noise here from the heat gun. And we see that the LED turns off. What we have here is a 1 kilo ohm thermistor in the circuit. You can see the LEDs on. We're about 12.8 degrees Celsius, you can see that. So our potentiometer here, if I increase, it's at 0 at the moment, it's varies between 0 and 1K. So if I increase the resistance of the pot, it's R2, to about 380, we should turn off our LED and activate the circuit. Okay, now we can see we're at a much higher heat and about 27 degrees. So we should have a much lower resistance to activate the circuit. So as you can see now, the temperature's decreased to around 22 degrees. LED's back on. So again, we need to increase the resistance in order to activate the circuit. So we can tune the circuit to activate at a certain temperature. Once it goes below that temperature, it's no longer active. So in other words, above that temperature, it stays active. So it's a way of turning something off when it reaches a certain temperature. So it's active for an increase in temperature.